Hello, everyone. So let me briefly introduce what is semantic AI. I think all of us know data is the fuel of AI, and the machine learns from data. But in our real world, actually the data may be generated from different sources and of different formats. Using the smart building as an example, as you can see, actually we can collect. Nowadays, buildings normally are equipped with an advanced building automation system, which is a network, okay, just like our internet, a network connecting a huge number of sensors and digital controllers and collect a huge amount of real-time measurement from the building. So when we look at a group of buildings and we aim to develop AI applications to different buildings, so the data format and also the physical meanings, how we name the data are very different for different buildings. So actually this created a very big challenge to how to mass deploy the AI applications in different buildings. So semantic AI actually is to address this challenge, to address the need for interpretable, meaningful, and machine-readable data. And it provides technologies to create this kind of data from the very beginning of the data lifecycle. That is where the data generated. And by fusing the knowledge graphs and machine learning. So here I show you a typical example we used in smart building, the graph, to represent the system. Okay, so this graph actually is an abstract organizational structure representing a set of entities, which represented by the nodes A, B, C, D here. So these nodes may be a physical component in our building system, such as an air handling unit, VAV variable air volume box, and it could be a sensor. Okay, and then the relations between the nodes, we call it, this is the edges, AB, AC, and CB here. So when we can use this kind of uniform graph to represent very different building service systems, and then actually it provides a very meaningful interface for the data scientist to develop AI applications. So when we're facing the diversity of the building systems, data from buildings, and also the format of the data, once we develop this semantic model, which represents the assets, the relationship, and data in the building, then we can use this semantic model to cover the diversity, to hide the diversity of buildings and the data. And based on this data, we can develop some application queries, the apps, so which can help us to query the semantic model to retrieve the data and the configuration it needs in developing AI model. So one of the purpose of this competition, actually, we want to promote the application of this kind of semantic model so that we can create the convenience of data scientists to deploy the AI applications across the building industry, no matter what type of building automation systems are installed in the building. So our current AI has already been adopted in the building industry, but this is the current situation. Normally, when we deal with one building, we develop the AI models from the data retrieved from this building. So when we deal with the other building, we need to develop the other model. So through this competition, actually we want to promote a model like this one. So we're using semantic model to hide the diversity of the systems, and then we can deploy the AI applications with a reusable and portable manner to different type of buildings. So that is why we need a semantic AI model. So I think for my colleagues in the OC organizing committee, they will introduce more about what kinds of semantic model we provide in this competition. Okay, thank you all. I hope you enjoy the competition.